Dear audience, my greetings from University of Ljubljana, Biotechnical Faculty, Department of Landscape Architecture, where I teach as an architect. It is self-evident that we architects talk about space. But do we really talk about space when we are thinking about urban planning and urban design, or we are talking about other features? Thinking of urban planning, we usually talk about people, society, people's needs, opportunities, strategies, politics, economics, uses of public spaces, material which we design, housing, nature, and so on. These features are in space, but they are not the space itself. My paper is about a pedagogical tool for perceiving space, also urban space, as a system with multiple dimensions. This tool is based on premises proved by mathematicians and physicists such as Benoit Mandelbrot, Michael Feigenbaum, and others. The question is, how can we teach urban planning and urban design in the contemporary moment where the neoliberal and pragmatic urban planning and design are prevailing? When we look at the contemporary urban, suburban, and peri-urban environments, we need to ask ourselves, why and when did spaces turn into places where we can no more feel at home? Why are all these places so alien to humans, though created by them? If this is a problem, in order to solve it, we first need to find the cause which has produced the problem, as we believe that the known reason can lead to a solution of a problem. In the first part of this paper, we will only allude to the problem, and then in the second part, we will explain our proposal for a possible solution. This proposal has been practiced for 10 years now as a pedagogical tool, believing that education is a basic step towards better solutions. My consideration would be that urban planning as a discipline must take a big part of the responsibility for the alienation from space, because it failed to realize that we have lost recognition of space somewhere far back in history. When did this happen? If we take a look at an example of the pre-Hellenistic period like the Dona theater, we can see that the scene of the theater is not just the landscape itself. The whole theater with its auditorium is embracing space. There is no doubt that space was then recognized as a divine entity where gods from the Olympus settled down and protected people. Even more, the characteristics of space were considered to be features of gods, to whom temples were raised as a proof that humans had recognized space and its protectors. But in the Greek cosmogony, there is an event where one of the titans, Kronos, castrates his father Uranus. Kronos, time, castrates Uranus, space. It seems that the consequences of this event didn't hit the Greek world before the Hellenistic expansion. Was the Hellenistic expansion the point in the history where recognition of space got lost? In general, we can say that the history of man became a constant battle for land. The divine space had been lost and land became an object with strategic, political, and economic values. Nature and landscape became an object of research and admiration on one side, and a profitable value on the globalized market on the other. The lost recognition of space and consequently the ignorance of its inherent characteristics might be one of the reasons that people do not feel at home in contemporary urban places. Urban planning has not been able to erase or even reduce the alienation, because it failed to see what had happened to space. Urban planning became a scientific discipline in the last century, but if we look at it precisely as a scientific paradigm, we find that since the first half of the 20th century, it has more or less developed into a compilation of other scientific disciplines like social sciences, economics, politics, geography, psychology, ecology, and so on. Here I would like to quote James Gleick, who said as early as 1987 that the models produced by economists, sociologists, psychologists, and urban planners, when they wanted to introduce strictness and rigor into the research of different systems changing in time, had become caricatures of reality. Traditional urbanistic analysis of urban site studies layers in space, demographic, economic, ecologic, its various uses, waters, floods, green systems, traffic, and many others. Researching layers, we try to find as much data as possible. And then, via computer programs, we try to get a strategy for the future development of a space. Yet, such strategy can hardly be realistic. However, the contemporary mathematicians have proved that these abstractions of the reality are misleading when we want to understand the complexity of the world. So, urban space is complex, not just because there are many elements in it, but as a system per se. If urban planning is a science, then it should shift its paradigm in accordance with the contemporary knowledge about complex systems, like it was developed by mathematicians and proved by physics. But then, is urban planning a pure science, or is it also an art? Is it both, or is it an art, which needs to be based on scientific knowledge about space? Should it not be necessary that we take into account the current knowledge about space, that we first consider space and then all the parameters in it? In the early 20th century, Albert Einstein found out that space is not made of particles. Therefore, urban space is not made of architecture. But as Einstein said further, particles influence space and space influences particles. Therefore, architecture influences space, and we might say that it should be created in such a way that the influence of space is not ignored. As Edmund Bacon said, architecture happens where space and matter meet. But what is an urban space then? According to the chaos theory, space is one of the complex, seemingly chaotic systems, and its characteristics are as follows. First, they have many changeable qualities and a stable one. This one persists while all the others are changing in time. Second, they possess self-similarity on different scales. Mandelbrot came across it while researching diagrams of prices on the market and the flows of rivers. He found similarities not only on small scales, but also on different scales. Mandelbrot penetratingly observed about art that accomplished art has no scale, but it includes important elements on all scales. To proceed, the third characteristic of seemingly chaotic systems like space is universality. In the 1970s, Michael Feigenbaum discussed universality in different complex systems. He found out that different nonlinear systems behave equally. The question we can now pose is how to include sciences about space in the pedagogical work with students of architecture, urban design, urban planning, and landscape architecture. Teaching at the Department of Landscape Architecture, where students do not have mathematics as subject and philosophy is optional, we have introduced examination of urban spaces through awareness that space is seemingly a chaotic system and that there might exist some analogous systems on smaller scales that can, in their characteristics, behave similarly to an analyzed space. Because of the small space, the latter can be observed as in a laboratory. An observation and research of an analogous system of a smaller scale, where we can find similar changing qualities as in the analyzed space, introduce a more than 3D understanding of space. With this tool, students are able to understand the space as a system in motion, a changeable system, with one stable characteristic. This is usually a huge step for students who are used to 2D and 3D design. By analogous systems, we try to find characteristics that are universal on all scales. Such analogies help students grasp more than 3 dimensions of an urban space. Consequently, they are able to create new urban spaces with an awareness of the complexity of given spaces. Let's see some of students' work using the tool of analogous systems. These examples deal with peri-urban and suburban spaces of Ljubljana. The first one is the case study of a suburban industrial zone where we mainly find light industry, offices, garages, a shopping mall, a gas station, and few individual houses. The district is degraded by many fenced parking areas, spread all over the place. Forms of public space are not present. There are no public parks in that district, but it borders on protected agricultural fields to which it has no connection. Students understood the reason for the degradation. They used Jenga as a possible analogous system where they stated that the voids of the degraded district filled with parking lots were similar to the voids of Jenga. When the voids are too many, Jenga becomes unstable and finally collapses. This thinking process resulted in the cognition that the voids of the district need to be redesigned into public spaces, which would stabilize the urban texture. The next case study was researching borders between town districts. As an analogy, students observed a classical mechanism of a watch. A thesis was set. As a cycling wheel depends on a circulation of another wheel, so a district's border depends on the border of a neighboring district. Just as degradation of an urban or suburban space negatively influences a neighboring district, similarly, an advancement of an urban or suburban border has a constructive impact across the district's borders. The students tried to make a harmonic relationship between suburban texture and the landscape according to the thinking process through the analogy. This case study was concerned with the reciprocal impact of the town's suburban and peri-urban districts and the landscape surrounding the town. Students understood these two different complex systems through an analogy of overlapping raindrop circles in the water. Where two different systems interfere, we found a potential node where we could harmonize the impact of urban texture with that of the landscape. This case study has research possibilities of how to connect the town center with the banks of the river Sava. It is a 4 to 5 kilometer distance, which could be walked in an hour, but is nowadays unwalkable due to physical but also mental barriers along the path. Students observed behavior of a liquid soap mixed with water as an analogous system, considering the reciprocal impacts of the town and the river. The observation of the system led to a thesis where the two impacts were understood as two systems colliding in several points in space. These points in the space were further understood as potential mixed-use urban nodes, generating urban spaces. The nodes could be connected to each other by pedestrian paths and thus connect the town center to the river. We see a part of the possible designed connections. The last case study shown here was researching the relationship between Ljubljana and its satellite town Medvode. Both towns are connected through Sava River Valley. Students understood the tension between the towns as a complex system of a magnetic field. At the same time, they studied the sequences of sprawl already degrading the river valley. The question was how to make the sprawl more compact and where green belts could be introduced to stop it. Students observed behavior of sand particles under the impact of natural forces such as wind and other horizontal influences. This analogy was simulated by a lab experiment and the process of the sand movement was studied. The third analogy for this case study was taken from pedestrians' movements in a square, observing especially places where people stop and how groups were formed. All these studies of analogous complex systems resulted in a redesign of the sprawl, in a design of connections between both towns, and last but not least, in architectural volumes, which are the result of the understanding of the space. Analogies of complex systems are used as a tool for a thinking process. A design then becomes its natural result. I need to emphasize that this tool cannot be used for copying complex forms of other systems into the architecture or urban design. A formally complex design would be a result of the described thinking process. Thank you.